In this video, I would like to provide a quick demonstration of how to use TI-84 to perform most of the assignments in Chapter 4 when you work with linear regression. On TI-84, you can enter the data provided to you, and I'm using this example that you see on the left-hand side. You click on Stat, Edit, and you need to enter X values in list 1 and Y values in list 2. Let me point out that you don't have to use list 1 or 2. Just choose any two lists you have available, or if you don't have any of them available, clear some lists and enter data into any two lists. In my case, they will be stored in list 1 and list 2. Just to make a quick demonstration of how to enter data into lists, let me enter a few of those values just for purpose of demonstration. So I'm going to enter X values into a list 4, a few of them, 15.6, 26, 34.3. If you need to move on to the next list to enter Y values corresponding to the X values, use cursor to move to the right and enter the data just like before. So I already did this work prior to recording this, and that's why you have the data already stored in list 1. That's my list for X values, and list 2 for Y values. Now we're going to go to Stat and Calc. One variable statistic is the feature of the calculator that can provide you a good summary of any set of data. Two variable statistics can do the same for two lists at the same time. So I'm going to choose two variable stats and identify where my data is stored, list 1, list 2, and press enter a few times. This first section gives me different things about X values. Mean for X values, sum of all X values, sum of squares of X values, sample standard deviation, population standard deviation, and number of values. There are 15 ordered pairs. The next set of numbers will give you the same quantities but for second list, the Y coordinates. Mean for Y coordinates, sum of all Y coordinates, sum of squares of all Y coordinates, sample standard deviation for Y coordinates, population standard deviation, and it also gives you the sum of the products of X and Y coordinates for each pair of points. It also provides minimum and maximum value in each set. Next thing I would like to show you is that you could also use one variable stat on just one list, and it depends on what your purpose is and what your needs are. I just wanted to point out that if I apply this function to a list of X values, it provides me with the same quantities we obtained before, but in addition, one variable stats provides you with the 5-number summary: minimum, quartile 1, median, quartile 3, and maximum value. So this could be used to come up with the box plot. Now let's come back to Stat and Calc menu. If you look below at option 4 and option 8, they both give you some information on linear regression. The only difference is that A value represents slope and what B value represents y-intercept in first case, and for option 8 they just swap their roles. You can scroll down to option 4, or you can just click 4 and choose that option. Let your calculator know where your X coordinates are stored in list 1 in my case, and your Y coordinates are stored, and by pressing enter a few times you will get the linear equation of the form y equals ax plus b, where a is slope and b is y-intercept, and these quantities are already computed for you. Everything that ALEKS wants you to do in very massive formulas you can bypass by using your TI-84. The next thing you see right now on the screen is an additional feature you would like to have on. By pressing mode and scrolling down to stat diagnostics, you need to turn it on by moving to the right and pressing enter to highlight that option. Now if you go back to Stat, Calc, and linear regression option, so I'm going to choose fourth option one more time. I'm going to apply this function to my lists Notice there are two more numbers that you see as a result. One of them, R, is the correlation coefficient that ALEKS may ask you to compute. Again, you can compute the slope, the y-intercept, and the correlation coefficient using formulas that ALEKS is providing for you. And I already gave you directions on how to do that. But you also can bypass all of that by using this linear regression function. If you need to get basic analysis of data, things like mean, standard deviation, quartiles, median, maximum, minimum, and so on, you can use the one variable stats if you need to get that for only one set of data, or you can use two variable stats if you want to perform that analysis for two sets at once. So to conclude, we found out that the slope of this regression line with the given data will be negative 0.49, and I got this number by rounding the result I see on the screen to 2 decimal places according to the directions. And y-intercept happens to be 41.58, again rounded to 2 decimal places. If you compare the solving process of the same question that I provided in another video where I used methods that ALEKS offers using the formulas, you probably will notice that even though the slope came out to be the same using that method, the y-intercept happened to be a little bit different. It came out to be 41.61, I believe. So that slight difference is due to rounding that we do everywhere when we compute mean of x's, mean of y, standard deviations for x and y. The formulas use rounded numbers. That's why the final outcome comes out slightly differently than what the calculator produces. Whether you do it by hand using formulas or you do it using the linear regression function on the calculator, your answer will be accepted because ALEKS will take a more precise answer like this one, 41.58, and will accept it, but it also will take the answer that you obtained using formulas as long as you used numbers around it properly. One more thing I would like to point out. In this same homework assignment, you will be asked different questions. Sometimes you will need to compute slope and y-intercept. Sometimes you will be asked only to compute slope or only to compute y-intercept. But you also may be asked to compute the sample correlation coefficient. In this case, it was provided to us. Here it is, negative 0.829. But I also want to point out that the same quantity, R, the sample correlation coefficient, can be computed using the calculator. This last number that you see on the screen is exactly what it has to be. Here it is, negative 0.829, rounded to 3 decimal places. In other words, what I'm saying is that the TI-84, which is required for this course, is capable of helping you to do a lot less of hard work that you would do otherwise using ALEKS methods. So feel free to use this function to do really most of the work in this chapter.